guys. I think I'll start now. So I'm going to talk about my experience in enterprise and implementing DevOps. So just a few words about me. Well, you can find the connection details later if you want to, but I like to position myself as a developer because I like writing code, and I am a developer. I mean, mostly Java developer, Ruby developer. But in recent years, like in the last few years, I've been involved a lot with helping organizations to automate software delivery and also to build a lot in terms of operations, of operating the live applications. So they say that in order to be remembered, you have to tell the story. And I'll start with the story as well. It's not a real story, it's a man-made-up story, but it's based on patterns that I've seen in different organizations that were trying to implement more effective software delivery. So imagine you have an organization where everything works in departments. You have a department of management, you have a department of IT operations, you have testers, you have developers. They live nicely in their silos, and they communicate more or less, maybe not that frequently, and they just give packages to the next department. Let's say testers test for that, IT operations deploy it. So this is pretty traditional setup for big organizations in Europe and the United States, pretty much everywhere in the world. People like separation. Well, imagine that we have such an organization. So at some point, our system administrator, let's call him Jack, or Yanis, or whatever, he gets a request from his manager saying, okay, we have a new secret project we want to deliver, and we need 10 developer servers to be set up for that. Well, that's what Jack does. That's what his job is, so no problem. He just goes in, orders the hardware, figure out the requirements for software configuration. He puts everything on, connects it to the network. After 2 days, let's say he has one server ready. After 5 days, he has another server ready, and he's working hard. He's making these things work. He's not really hurrying up, but still. And while he was doing that, he gets another email from another girl who is apparently is the project manager for the secret project, and she says that, you know, Jack, we need those servers now because we already have developers waiting for start deploying their first tryouts, and we really want this to be done. Well, no problem. But at the same time, Jack also has his own department, his own rules, which says that, and then Jack's boss also about the same time sends him an email that, you know, you're setting up these servers, but you know, we have to document everything. We have to describe what we set up, we have to follow the procedures. And that's fine, that's what Jack does. And he delivers all the servers, delivers all the documentation, because that's his job. He gives it to the developers and they start working. He provides the documentation and everybody's happy, kind of. In the meanwhile, there's a new change request coming in, and this change request is coming from, you know, from some other department through Jack's manager, and the change that is requested is not related to what developers are doing, but Jack's manager said that you have to implement that, and well, Jack has to obey it. That's his job. But the problem is that developers are also using those servers, and at the same time, they were trying to deploy to dev servers while Jack was making the change that was proposed by through some secret channel that he didn't know about. So developers are not happy, and Jack, of course, he had to fix it. And let's say at 3 AM at the night, he fixes everything and sends email to the developers saying, okay, guys, now you can use the service again. So the clash between developers and operations appears for the first time. But the problem is that things are getting worse because the more CRs are coming from different, sorry, just need a bit of water. More CRs, change requests are coming from different directions, and Jack has to handle them. But the problem with the environments, with the servers that he sets up, is that with handling all these chaotic change requests, the environments, the servers are going into unknown state. And at that point, documentation is very much outdated and pretty much unusable because it doesn't reflect what is on the service because nobody knows what is on the service. Just they work somehow. What you basically get is chaos. Well, at this point, probably the development is already over, and testers are going onto the environments, and they need a new environment for testing, and they flood Jack with more requests, sometimes not even understanding what they're asking for. And the problem is Jack has to now deal with many environments at the same time, and given that the development environment was in the unknown state, making other environments better is pretty much impossible. And at that point, documentation is just thrown away because nobody can update it anyway. And, well, he just works to make it. And at the same time, the go live date appears. So what happens here? In order to fix all these configuration problems, deployment problems, the usual way of approaching that is to throw more people at that, or work very hard at nights and weekends too, in order to solve the operational problems that were not considered before. And well, the code goes to the second project goes to production, and clients started using that. And apparently, everything doesn't work that well because everybody is going into supporting production environment, and the other environments where developers and testers are still doing something, they pretty much left out of attention. And new code is coming in, and we see fire in production because nobody thought about this setting and that setting. From one side, well, the code is working. It's kind of starting to bring money, starting to bring clients, but still there are problems in production. And the first question, what you would ask operations guys, do you have monitoring? And well, they say, yeah, we do have it. We have it, and we use it. But the problem is that the dashboards that operations has, they show, let's say, that CPU is not loaded, that memory is not full, the disk is not full, but the application actually is not working. So they're monitoring the wrong thing. And it appears that the manager of the project or the client support of the project gets information about something not working earlier than operations people do. And that's, of course, that's a bad situation. And that's what I observed a few times where operational guys, they show me green dashboards, but they don't react to avatar obvious problem. At this point, what these guys can sell, the only thing they can tell you is that, sorry, we just were doing our best, we're busy, we're working all the time. Is there any happy ending to that? Is there any way to improve this? But first of all, before we see how to improve that and how to talk to the possible ways of how to do that, first of all, let's try to see what the problem is. And obviously, like in many cases in software development, the problem is in communication. Because software is developed by people and for people. And if you don't communicate with each other, then obviously you don't deliver a good thing. So if you look at the way developers and operations usually interact within a big enterprise where they're separated in departments, it happens, the deliveries are going in one direction. So the feedback from not working application is not going fully back to developers. So the developers really don't feel the pain they produce to operations guys. But operations guys work hard to make what developers do live. And also the communication can also be broken because it happens on the management level, it doesn't happen on between people who are doing stuff. So the feedback loop is not full and it's broken. Another issue that I have noticed when working with the different operations department is that, well, developers, they pretty much more or less agree on agile methodologies, and they work, they're separated into more or less small, big teams working on certain products and projects. They more or less have an agreement with each other, and then they are rather democratic in a way. So we can call it like development republic. On the other side, operations are more traditional. They really are separating what they do even more than they actually could. So given this border between developers and operations, also there are borders inside the operation themselves. So some people are focusing on monitoring, some people are focusing on networks, some are doing all the infrastructure, and then that in a way makes sense. But the communication level between them is really, really low. Actually, just today I was working with one client who had a department who were only focusing on load balancers. So in order to get like information about why the application is not performing, I need to connect to a guy who is supporting load balancers. That's really annoying when you're trying to solve a problem and you need to go this path to find the cause of that. It's really, really pain in the ass. This also comparing like developers and operations. The thing is that developers, they are producing changes, they're producing new stuff. And they want to do it as quick as possible, and they want to produce as much code changes as possible to deliver new features, to deliver new functionality. On the other hand, operations, they like stability. They like the systems to be working and to be up and running. And it may seem that there is like a conflict between stability and agility when you talk between operations and developers. But in fact, the agile approach can be stable as well. There's no conflict in fact, but that's where it comes to if you look at the problem. And in the environments where you have this kind of separation, where the operations are responsible for code deployment and where they are responsible for putting stuff and supporting it in production, it could be that they actually have fear of deploy, because the systems have so many integration points and they're so fragile that every time you try to deploy, something breaks. And this basically leads to a fear of deploy, because you may lead to a situation where you would like to prolong your development cycle because you want to reduce the number of problems, but in fact you actually increase the number of problems. And like agile methodologies teach us that in order to find the problem, you need to face it more often. Another interesting concept that may show how operational approaches influence the whole organization is the amount of unplanned work that is hitting the operational department or organization as a whole. And this chart basically shows that if the number of failed or unauthorized changes, and in this statement I want to say that it's number of changes that are done to the environments or to the code or to the way you deploy your applications is done in an unplanned or unallowed or unagreed way. If this number of changes is growing, this directly influences the amount of unplanned work that your developers, your operations will have. And obviously, if the amount of work grows bigger than the amount of time you have, this may kill your organization eventually. Another thing that may influence the unplanned work is the number of unique configurations that you have in your environments. And that may mean like different versions of operating systems, different versions of hardware, different versions of application servers, different Ruby versions, Java versions that you have to support. If the number of unique configurations that you have in your organization is growing with time, then obviously the mastery that you can apply to each of those configurations is dropping. Because you can't really be like a master of everything. The more you have to master, the less master you are of each one of them. And this obviously also, because you don't have enough knowledge, enough skill in managing all your different configuration, the success change rate is actually dropping. And this obviously can also influence the amount of unplanned work that your organization have. And that's what can eventually kill any even successful organization. And DevOps is there to actually, the DevOps principles is there to actually try to solve this organizational challenges that appear between development of the code, the changes that you produce to your applications, and the operational part of that. So the first principle, I would say that it's important to fix the communication between developers and operations, because it's very important to have an application that is not only quickly developed, but also effectively maintained. And the more we grow in this industry, the more it's becomes apparent. So obviously, the people should talk to each other more, and the right people should talk to the right people, because otherwise it's really a waste of time. And as you see, that this picture kind of reminds a bit of a football field. So you're actually playing the game. You have different goals. Each like group, like developers and operations, they have different goals. Agility versus stability. But on the other hand, they should make a good show, because their clients are actually sitting on tribunes and looking at them. So having worked together, making a good game and playing by the rules will produce a good game, and makes your client, just spectators, happy. Another important thing is that the feedback loop between developers and operations should go in a way that information is shared, and stuff that happens in development should be delivered to operations, so they know how to deploy, how to provision, how to set up, how to configure the application. And operations should also give feedback to, okay, we deployed this application, but we don't like the way these performance settings are set up. Please change it on the development version as well. So things like that should happen continuously in order to improve not only the functionality of the application, but also the operational aspect of that. As I mentioned, like the feedback loop is important in software delivery, no matter what we do, and including operations in that loop is damn important. So, important part is obviously that, well, if you want to increase the visibility, the communication, then sharing visibility between different departments that is what is important. And if your testers, if your developers, if your operations, they share the same view of what is happening, and if they share the same goal, trying to make the application better, that's where DevOps starts. So the focus on DevOps is actually on automating of tasks performed during the whole software delivery cycle. So testing, deployment, maintenance, monitoring, all this stuff should be automated. And this is probably the only way to reduce the risk and to remove the fear of deploy, because if your deployment is repeatable, if your operations are reliable, then you can actually start delivering more changes. So by introducing this stability part inside your software delivery processes, will actually also give you the agility that you might need. And looking at the charts from planned work in the beginning, so if we, by introducing more automation, by introducing more agreed approaches, so everybody in the chain agrees on how we do it, this will definitely reduce the number of unauthorized changes or failed changes. And given the same success change rate, the work planned work will actually go down. The same happens with the number of unique configurations. So if you can agree on something between your team members or different teams or different departments, that we only use, I don't know, Linux, or we only use Windows for deployments or whatever, or we only use this version of Java with this version of Ruby deployed to this application server, then the number of unique configurations obviously is going down. And this also leads to a situation where the mastery of each configuration that you have is growing. So the fewer configuration you have, the more time and the more skill you can invest into making this configuration perfect and making it more automated and making it more supportable. And obviously, if you are mastering your configuration better, then the success change rate is growing, and then planned work is also going down. Okay, great. Now you've kind of heard about DevOps, you know what it is. Let's try to do it. It will definitely save you, or save me. But the problem is that there are failed expectations. And like with the Agile, like if you remember, in the beginning, everybody was doing Agile. Everybody was expecting that Agile would work, but it worked maybe for only for a few. The same happens with DevOps, because it's not about how you do it, or it's not about like what kind of magic you do. It's really about cultural points. And if you can build a team that follow the principles, then it doesn't matter how you call it. I mean, it's really about trying to reduce the feedback loop. And also now, like well, the same with Agile. DevOps has a lot of misconception, misunderstanding of what it is. Some people think that DevOps is just a new name for system administrators. Some people think that DevOps is just a guy who writes build scripts. But in reality, it's not really about that. It's not really about what you do and how you do. It's really about some basic principles, which are not that much different from what Agile promotes. It's just also includes the operational part. How you do it doesn't really matter. And most people, when they hear about DevOps, when they dive into this topic, and trying to implement DevOps in their organization, they start with the tools. And so did I. I also did start with the tools, and it's totally fine. I mean, it's a logical step. But the problem is that tools that you use are as important as the culture aspect, like internal culture of what you have inside your organization. Because if people don't believe in Agile, if people don't believe in DevOps, I mean, it doesn't matter. I mean, it's because DevOps is not really only about tooling. And I found this very nice acronym that defines DevOps in a similar way. So basically, it's like four words: culture, automation, measurement, and sharing. All these four components contribute to DevOps implementation inside your organization. So culture means that people are more important than processes and tools, and software is made for people and by people. Automation is an essential part of DevOps because it's the only way to reduce the feedback loop that you have between when producing the change, submitting your stuff into Git or SVN, and to deploying this code into production and verifying that it actually works. Measurement is also an essential part because this is the only way to produce the visibility of everything. And if you can measure how much your software deployment takes, or if you can measure how well your application operates, this is an important input to the whole team. And also, giving that the measurements are visible to the whole team is also important part of the next step, like sharing. So if everything that you do is shared, automation, measurements, and then culture, then this leads to effective implementation of DevOps. Okay, now I'm switching to more like technical part of my presentation, where I try to give some advice of how can devs and ops help each other. It's a bit less high level. But first of all, in order to, yeah, I need to talk more. Developers and operations, oh sorry. It often happens that, especially in big organizations, that system administrators and developer team, they sit in different floors of different buildings or even different countries, and they don't really talk to each other. So in order to improve this, like DevOps approach and make it better, of course you have to talk more. And you have to share pretty much everything that you can, including every script, every configuration setting. Everything should be shared, because otherwise it's really hard to get an overview. It's really hard to make a common approach. So let's go to the technical part. So hints for developers, first of all. By the way, how many developers are here? Like, well, pretty much almost everybody. So that's another tendency among developers. They tend to ignore operations, or they tend to think of them as like low-level creatures who are not really worth their attention. But in fact, now I have a lot of friends among operations, and they're really good guys. They're really smart guys, in fact. And the two things that I would advise to avoid when developers are moving fast and they think that the operational part is actually slow for them, they go into this like shadow ops mode. They could go into this shadow ops mode where they just ignore what operations do. They ignore security, they ignore backing up, they ignore monitoring, they just deliver features. And that may appear that eventually will be a bad result. Also, there's also another tendency that's sometimes appearing, that developers decide that they can actually do operations by themselves. And given that we have a lot of like cloud providers now, and a lot of them are API based, it may seem that it's actually possible. And in early stages, I would say it is possible. But if you go in more advanced mode, then you would need someone with operations experience. And that, well, if you ignore operations, you can go into DevOps mode. Okay. So the most important part, or one of the most important parts of any for any application operation is logging. And the thing is that I've seen a lot of polluted logs produced by many applications where logs become unreadable or too noisy. And the thing is that whenever you write a logging statement in your code, just think about the guy who may read that statement at some point later. Because if at logging level, messaging, like the message of the log, the frequency of logging messages that you produce actually may help later on in solving production problems or solving also business problems, depending on what it is. It's very important to produce clean and meaningful logs instead of producing a lot of debug and tracing. For example, well, this log is kind of pretty much unreadable. It's taken from some Windows file. I don't even know what it is. Message tracking log. But this log is not. Maybe it is machine readable, but it's definitely not human readable. Definitely not parsable, even if you know what these numbers mean. Another important aspect of any application is the configuration of that. And I'm pretty sure that most of you have implemented a set of like YAML files or property files or a database that configures your application. But also, on the other hand, I've seen so many applications that were having very messy configurations, like very messy configuration parameter names with unlogical defaults and hidden parameters. So having, and also like configuration names breaking between different versions of the application, having those combining and having good defaults and good naming for your configuration has the same purpose as having good logging. Because someone, presumably someone from operations, will actually try to read this configuration settings, try to guess what these parameters mean, and whether this is a good value or bad value, and will try to match them if he tries to deploy the new version of configuration. So it's important to give it like normal attitude, like you would have with the code. So if you are like a clean code, the person who likes to write clean code, creating a clean configuration has pretty much the same purpose. For example, who recognizes this? Who has Windows computers still, like me? Not many. So this is a Windows registry. So if you can look at that, it's very messy. Right? Who would have a place like don't load and desktop on the same level? Or what the heck is MMCPL? Nobody knows. And
that's a virus.
Sorry.
That's a virus, okay.
could be a virus. But in any case, I hope you notice that there is no consistency in here. And imagine like configuration is another type of interface that your application have. So imagine someone having like a HTML form like this. Would any user will be happy to use that? Probably not. Or I don't know. And then, well, this is pretty unlogical, pretty confusing, and because configuration actually is not done for computers, it's done for people to use it. It should be logical, it should have good naming conventions, and this is just a bad example. Another part that developers quite often leave aside for their applications, that their applications are not always monitorable. So it's now things that the only way to get something out of application is to enable debug logging, but monitoring is a bit different beast. It's important to have some channels to extract information about running application. And from this point of view, it would be good to know what your operations guys are actually using to monitor. So to know the standards that your that the operations guys are using. So if it's Java applications, probably it could be JMX or SNMP. And usually, most monitoring solutions already are supporting HTTP as the main protocol. But in general, knowing what your operations are, monitoring which protocols they're using, and exposing this information to them in the same protocols would be very, very good for them and for application in general. Obviously, that monitoring metrics should include like some vitals that show the application healthy. Well, CPU, memory, disk are the ones that are monitored pretty much by everyone. But if we go to application level, it could be some different kind of resource pools, connection pools that are used by applications. So having the state of that component exposed in terms of monitoring will be very great later on when you have to analyze problems in production. Also, different types of transactions, requests, operations per second, per minute, per hour. These statistics can usually be exposed by application and be also very useful for looking how effective you are. And also, probably there should be like separation between technical metrics and then business metrics, because business metrics could be like the customers you have served, the amount of products you have sold. This can also be exposed in monitoring tools and quite easily consumed. Also, as part of development, in fact, I would insist creating dashboards, because if you create a dashboard when you're developing the application, you also understand more how your application operates. Because if you create a dashboard later on, when the application is already in production and running for a couple of years, or months, or weeks, then it's already too late. Because, but if you can create this kind of dashboard where you put the most important information about your application, then it's already giving you a good insight about how your application works, and you can compare that application work in different environments. It could be like, there's test-driven development, there could be dashboard-driven development as well, which puts a bit of impact of how you design your application, exposing monitoring data, exposing logging data. If your monitoring and your logging data can be put into a nice dashboard, which this is a good thing for application in general. Another important aspect for developers or for operations as well, to align the requirements for production system or to align the requirements for at least for testing system early enough. Because it often happens that in the traditional way that we described at the beginning of the story, that the operational part comes very late in the process. And let's say if development goes pretty much all the time, and then you reach the testing mode, you fix a number of issues that you find, and then here the manager says, okay, we are good to go to production. But the problem is that because operational aspect was not considered before that point, when it goes to production or when it goes to more real environment, then you start to hit the number of issues that were not seen before. From development point of view, I would say that you have to learn some of the provisioning tools that exist out there. Puppet, Chef, Ansible, Solid, probably four topmost of them, but probably there are some others appearing now. Well, at least knowing bash scripting is again, quite beneficial. Because you can basically express your requirements to operations in form of the code. In form of, it's called instructions code basically, where you define what you need from architectural point of view, from operational point of view, you define and give it to operational guys. So instead of writing a document, you actually can write a piece of code and test that code and then give it to guys who support production, and they will just use it and deploy exactly the same stuff you actually use in development. Also, by having this provisioning software used by your team, you can also, and using some virtualization tools that you have like VirtualBox or Parallels or some cloud, you can actually build a clone of production environment that is using the same direct system version, having the same components, having the same configuration, and it just runs on virtual machine inside your laptop. So that's all possible, and that's if you can achieve that, then that will be a solution to many problems that will never appear. If you don't use background, or if you probably have to, and as you see, starting a new machine it's a single file that defines the type of machine you want, now the amount of memory, what operating system, what kind of provision do we want to run, It's a single build file. You just say bunker top in the directory where the file is, and then you get the virtual machine running in your laptop, like in a matter of minutes. That's going to be probably the same machine, the same type of machine that is running in production. And basically, things that you would probably like to achieve is to reduce the number of differences you have between your local development setup, local development environment, and things you have in production. And again, mentioning these tools like Vagrant and Docker and VirtualBox and different cloud providers, if you can really reduce the difference between production and development, then this will reduce the number of problems that you will actually have during the operational part. And this is where the organization from the story is, and this is where probably the continuous delivery mode is, where you have everything pretty much the same, or even in a very extreme case where your development environment actually is the production environment. But that's probably a bit too extreme. Another interesting aspect is that developers may not usually package their applications to be delivered, to be deployed as a single package. But this is again, this is a good interface towards system administrators, because most of them know how to deploy an RPM or deploy a Debian package. And if you can package your application and give them this single package instead of giving them, oh, you know, there's a source code and Git lying somewhere, just use it. Then they will just say thank you to you, because it's much easier to deploy a single package than to deploy code with the which deployment description is described like in a document. Also, artifact repositories definitely needs to be used to version artifacts that are deployed to production, and the process could be kind of similar to this. So you keep your code in version control, and it builds and tests and releases into artifact repository, and then from there, the deployment procedure and provisioning procedure is taking the whole thing and deploying it to infrastructure. And then meaning that not only the application code, but also the provisioning code and configuration and tests, they all are kept in version control, kept in the artifact repository, and the automation part is deploying that to the server. So pretty much like this. All artifacts are kept in version control, and it's the responsibility of automation procedures to put this, to provision the state of this infrastructure, but it's not the responsibility of people who are doing that. So the authorized way of doing things is through version control and automation, not through doing SSH to your server and manually copying some stuff. For developers, obviously, so it's important to automate everything, because if you can automate everything in development, you can definitely automate the same in production. Now I'm going to talk into operational guys. Any sysadmins here? Okay, few. So, first of all, in terms of problem solving that you see in production, well, get those Dev developers to help you with that. Because if you see a problem in production, and this is a problem with the application, get the developer, and it doesn't matter, it could be like a weekend or not in the night, but get the developer there and let him fix the problem and help you fix the problem. And also look at how he did it and remember it. Again, there's nothing more that can be advised like creating a good monitoring for operations guys, creating dashboards, many and meaningful, and analyze what's happening, and then create alerts as well. Also for logging, because developers are kind of sometimes messy with the way they do logs. Analyze and aggregate logs in a single location, and analyze what's happening with them, and give feedback to developers. So they clean up the logs, reduce it to the level, remove some noisy stuff. Also, like log rotation and cleaning logs from time to time is an important aspect. Again, the same advice for operations guys. Learn how to use provisioning tools, because this is like an interface between operations and developers to express automation, conversion automation in form of the scripts of the code. And if you can use this between your developers and operations teams, then this is the language that basically glues two teams together. That's what is infrastructure as code. So you define what you need in form of the code. Basically, all the architectures, all the deployments can be described in form of the code. Also, I found that sometimes a bit hard for system administrators, especially for ones that are working very traditional organizations. It's very hard to use version control. They don't like using it, or they ignore using it, or they use some special version control apart from developers. So of course it's important to keep stuff, well, if you express your processes in form of the code, then obviously the best place for the code is version control, there's no other place. And as I mentioned, the feedback loop should be full. It should be not just one way, it should be two-way. And giving changes back to developers, giving them feedback about how their logging is working, how their configuration sucks, it should be both ways. And yeah, of course, operations guys should be prepared for this also, because they are the ones who are going to be there in the first place, and they need to know how to make backups and how to restore the backups. That's another important aspect, because I've seen so many times people are doing backups, yes, but they don't know how to restore from them because they never tried it. And of course, capacity planning, like if you see that your load is growing, then obviously the number of servers should be increased. Okay, I'm pretty much done. Just a few words in the end. So I guess most of you know this about this technologies that is worth following, and in terms of more automation and more infrastructure as code approach. Like VirtualBox, VMware, Parallels, plus Vagrant, Docker, and there's a huge offer of clouds that exist, like AWS, Azure, Google Cloud, all of them. And if you want to go to private cloud, you can use OpenStack. Again, I'm mentioning these tools like third time, but I think it's an important part of like the automation and DevOps, like PowerShell, Ansible, Salt, or you can write your own if you want. But those are kind of good ones. For infrastructure monitoring, I would recommend like Logstash plus Kibana. This is more like log aggregation, and this is very trending at the moment. For monitoring, my personal preference is like Graphite and Grafana, Grafana is kind of the same stuff as Kibana, just for monitoring. Also, I use sometimes dashing as a way to express dashboards. Those are a few companies that you may follow if you want to like move into more like automation and DevOps move, like Spotify, Netflix, Etsy, Twitter, Amazon. Well, actually, some of these companies were doing DevOps even before the word DevOps existed. So they're very fancy ones. Some reading stuff on the topic. Well, this is quite an interesting book because it's not a technical book. It's actually a fictional book. It's kind of similar to the story that I told you, just a bit more advanced. And it tells a story about an operations manager who was trying to save a big organization. So it's actually very easy to read, and it's
fun to read.
Sorry?
Fun to read.
Yeah, absolutely. It is fun to read, and it's written by one of the guys who wrote this is Jim Kim, who is very active now in the DevOps community. So it's really interesting read. Of course, it's always that DevOps and continuous delivery, they come like hand in hand, and in fact, a lot of tools that I mentioned here, they also mentioned in continuous delivery, and I think that it's impossible to implement continuous delivery without having a good DevOps approach inside your organization. There's also another good book from a Danish guy, Michael Nugert, kind of similar to continuous delivery, but from a bit different aspect. Also, in terms of like preparing for disaster, there's another book called Inviting Disaster, where it doesn't talk about IT in general. It talks about different catastrophes that happen in humankind, how they could have been prevented, and what are the principles behind that. So it's also quite an interesting read. Also, there are some blogs like enterprisedevops.com and itrevolution.com, which is written by Jim Kim and his friends. So it's, again, if you want to follow that topic, those are interesting reads as well. Okay, any questions? Thank you then.